This video is about making things work, and it comes up in P3 Part 2 AQA. So one of the things you need to know about is centre of mass, and you need to be able to find out how to work out the centre of mass. There's two different ways. One is for irregular shaped objects. So this has come up before, I think about 2 years ago, and it was 5 marks to describe how to find the centre of mass for an irregular shaped object. So the way you do this is you get your object and you suspend a plumb line, so basically just some string with a mass on the bottom, and then where it falls freely you then note down with dash lines where that is. You then suspend it from a different point, again where that falls freely it will wobble. You then put another line, and where the two intersect is where you will find the centre of mass. Now the centre of mass is the point at which all the mass appears to be concentrated. So it doesn't necessarily mean it is, it just appears. You can actually get centre of mass inside like a tyre, so something with no mass in the middle, but that's where the centre of mass would be. For symmetrical objects it's a bit more simple, so basically it's just where the line of symmetries cross, that's where you get your centre of mass. They can also relate it to toppling objects, so they might ask you whether an object would topple over or not if it was pushed to a certain extent. So this is all to do with the line of action. Now the line of action is goes through the object's centre of mass. If the line of action is within the base, it will not topple. So if you had like something went around a corner, it went like this, but it wasn't over its centre, the line of action wasn't over its base, it wouldn't topple. However, say if you had a double-decker bus and everybody sat on top and it went around a corner really quickly, it would topple over if the line of action went outside of the base. You can also then relate that to increasing stability, so making it more stable. You can do this by lowering the centre of mass. If you have a lower centre of mass, it's more unlikely that it's going to go outside the base. And also you could increase the base width, which is why things like traffic cones have a wide base. Okay, pendulums. It's basically a heavy object attached to one end of a long, thin piece of material. Could be wood, could be string, but as long as it has that tension there, that's fine. The thing on the end, the mass on the end, is actually called a bob, which is quite cute, I find. Now a time period is the amount of time it takes from, say if I pulled this bob back here to A, to go to B and to come back again. So the time period is time to swing from A to B and back. Now there's actually a formula for this. The time period in seconds is equal to 1, just the number 1, divided by the frequency, okay, so the number of oscillations per second. It's affected only by the length of the actual pendulum itself. It's not affected by the mass of the bob. I don't know if you've ever seen this really wicked physicist called Walter Lewin. He actually gets on the end of a bob and swings himself, and it's not affected at all. Even changing the degree at which it is it's dropped at, even if it's really extended, it will affect it, but even doing that will not affect its time period, only the length of the pendulum itself. Examples of pendulums would be things like swings or grandfather clocks. So moments, I really like moments. So moment is basically the turning force about a pivot. It makes things easier for us. The formula for moments is moments measured in Newton meters is equal to the force in newtons times the distance in meters. Again, distances meters, they might be mean, they might tell you in kilometers or tell you in centimeters, just make sure you convert it, okay? So, for example here, if we had a spanner and I had it at a length of 0.2 meters and I applied a force perpendicular of 50 newtons, the moment would be this times this, so it would be 10 newton meters. If, however, though, I doubled my length of my lever and I half my force, I still have the same moment. So increasing the distance of your lever, or the distance from the pivot point, actually means that you can apply less force, which is really good when you're trying to like lift heavy objects. If you've ever tried to open a paint tin, a long screwdriver is a lot better than a short screwdriver. Then they have this something called the principle of moments. Now this is for balanced objects, so like a seesaw. if something is balanced, then that means that the moments on either side must be equal. So there's this famous thing, could a bunny rabbit lift an elephant? Well, yeah, effectively, if they were on a seesaw and the moments equaled out, then yeah, it could. So for this, the formula is the force of the anticlockwise moment times the distance of the anticlockwise moment would be equal to the force of the clockwise moment times the distance of the clockwise moment. And if those two equal out, then they will balance. So in this situation, they could tell you 3 of the factors and ask you to work out the other one. But they will not tell you this. You need to remember this. Principal moments, anticlockwise moment equals the clockwise moment. Levers are force multipliers. So it's if they have a pivot and you have a lever and you have in a moment, it's able to increase the force by increasing the lever. Okay, so we go here, circular motion. Okay, so basically circular motion is acceleration in a circle. So as we know from P2, if your velocity is continually changing from your direction, you are accelerating. And this, the tension, if say you were swinging something around, or the gravity from a planet around a sun, causes a centripetal force and it acts towards the centre, okay? You can increase the centripetal force by either increasing the mass or increasing the speed or decreasing the radius. Pressure in liquids comes up. Now, they like to ask this, pressure in liquids acts equally in all directions, okay? It's not just above, it's not just at the side, it is all directions. They can sometimes ask you this liquids are almost incompressible. It's a tiny, weeny little bit you can compress them, but this is really almost incompressible is a really key phrase there. When you're working out pressure and force and area, so it's force in newtons, pressure in pascals or Newton/meters squared, and the area is in meters squared. Now this is a really important thing. They will be horrible and give you in centimetres. You need to change centimetres squared into meters squared. It's not the same as just divided by 1,000, okay? Because we're now squaring it. So to get centimetres squared into meters squared, it's divided by 10,000. This comes up in things like hydraulics. So if you had a small area and a force, you can then multiply that force from a larger area and it will increase the force. This happens in things like brake pedals. When you have a hydraulic brake system, you put your foot on the brake pedal and that will multiply the force to the brakes because it has 4 different places. Then we have electromagnets, okay? So current will actually create a magnetic field. So whenever you have current going through anything, it will generate a magnetic field around it. So if this was a wire with current, the magnetic field would go around it. Quite a weak magnetic field. So the way you could increase that is if you actually loop around your wire and create a solenoid, it will actually concentrate the magnetic field and give you a stronger magnet. So you could increase the current to get a bigger magnetic field or increase the number of coils. The motor effect, so how this can be used, is if you intersect a magnetic field when you have a current going through a wire, it will cause the wire to either move up or down depending on where it is. Now the way you know this is from Fleming's left-hand rule. So the movement is your thumb, it's got an M in it. Your first finger is your force field and your second finger is your current, okay? So you need to do north to south for your force field and you need to do positive to negative for your current. And you will in the exam be going like this, okay, but it's your left hand you have to use. I think it came up last year, so whether it will again, I don't know. Now you can change the direction of the movement by either reversing the magnetic field, so changing this around, or you can reverse the current direction. And it's sometimes related to and used in it is used in loudspeakers to get the vibrations. Transformers are used to increase and decrease current. So it happens like this. So you have a coil of iron, it's not a magnet, and then you have a current going through and a number of coils on one side. So this would be a step-up transformer because we're actually increasing the number of coils on the secondary coil. So you have a primary and a secondary. and then you can have another one there and it would transfer it across because of electromagnetic induction, and that's how you can increase and decrease current. It's sometimes related to this formula here: voltage of the primary coil divided by the voltage of the secondary coil is equal to the number of coils on the primary divided by the number of coils on the secondary. So again, they could give you 3 factors, ask you to work out one. Just don't get confused with the whole which goes where. If you were trying to work out, for example, number of primary coils, you'd have to bring this one up here and stuff like that. So just don't write it out as it is in the formula, put the numbers in and then try rearrange, because at least you get one more for putting it in right. If you actually just put a magnet inside a coil of wire in and out, that will actually induce a current. So that's how we actually do our electricity in power stations. We have a magnet rotating inside a copper coil. Switch mode transformers, you need a bit more research on those, are things for like TVs, mobiles, things that need a lower voltage than 230 volts that we get from the mains. So they can do that. That is quite a clever way to do it. It's related to this sometimes: the voltage of the primary times the current of the primary equals the voltage on the secondary times the current on the primary. So make sure you research your notes for all of these.